In this video, we will be showing you a demonstration of a concept known as the no-slip condition. The no-slip condition states that because of viscosity at boundaries, particles of fluid will adhere to the walls. Therefore, the fluid moves with a velocity of 0 relative to the wall. You will need a glass bowl, a smaller glass, a shot glass works best, water, a straw, and dye. We used McCormick's food coloring for our dye. To explain this in simpler terms, if a current is to flow between two walls, the velocity of the current next to the wall would be 0. Since the wall is not moving, the water therefore would be stationary by the wall and be fast in the middle. A great example of this would be in a river. In a river, the water by the banks is calm and stationary, while in the middle the current moves faster and is more turbulent.
On the other hand, if there is no current and the wall is moving instead, the water moves with a velocity that is equal to the wall that it is touching, and its velocity slows down as you move away from the wall. An example of this is a boat on a lake, since a lake has little to no current. As the boat moves through the water, it leaves a wake behind it. The wake is partially caused by the water in the lake sticking to the side of the boat and beginning to move at the same velocity as the boat. The further away from the boat that you move, though, the velocity slows down until it reaches 0 and the lake is calm once again.
For our first example, we moved a straw through the middle of the water, creating a current there in what should be a 0 velocity area by the side of the bowl and by the shot glass, with the fastest velocity in the center. After creating a current, we added 1 drop of dye to the area by the shot glass. If you look at how the dye moves, you can see that it hardly moves by the glass, and it is instead drawn to the center of the flow where the velocity is highest. There it begins to move faster.
In our second example, we first added the dye by the shot glass. We then moved the shot glass to create the fastest velocity by the glass while keeping a 0 velocity area by the bowl. You can see here where the dye moved the fastest by the glass and the dye further away barely moves or doesn't move at all. In this shot, you can see the velocity profile of this flow. In our third example, we added the dye by the side of the bowl. We then spun the bowl while holding the shot glass still. As it was done, you can see that the dye remained by the side of the bowl, moving at the same velocity, and only barely moved inward to the 0 velocity area by the side of the shot glass.
For our final demonstration, we used the same method as we did in the first example. Our only change was that we dropped 2 different colored dyes by both the edge of the shot glass and the edge of the bowl. We did this to show that they would hardly mix, as they were mostly in the 0 velocity area. They only mixed in the middle where they were pulled into the fastest velocity flow. This concludes our demonstration of the no-slip condition.